Welcome to today's Explainer. Today we're diving straight into a field that is literally manipulating the invisible to reshape the reality we live in every single day. We are talking about nanotechnology. We're going to explore how manipulating the microscopic world completely transforms our macro world, from the medicine we take right down to the screens we're looking at.
Here's our roadmap for today. Number 1, into the nanoscale. 2, why small changes everything. 3, building atom by atom. 4, meet the nanoparticles. 5, real-world nano applications. And finally, number 6, future impacts and challenges.
Section 1. Into the nanoscale, shrinking down to a billionth of a meter.
So what exactly is nanotechnology? Well, it's the science and engineering of materials and devices right at the nanoscale, typically between 1 and 100 nanometers. It's really important to note, this isn't just about passively observing things that are tiny. It's about actively building and engineering them from the ground up.
To put that in perspective, 1 nanometer is exactly 1 billionth of a meter, or, mathematically, 10 to the negative 9 meters. It's a scale where our normal, everyday frames of reference completely fall apart.
Let's try to visualize this descent into the microscopic, because it's honestly mind-bending. If you start with a tennis ball at 10 to the negative 1 meters and shrink way down, past a grain of sand, past the width of a human hair, past a single red blood cell, and even past a virus, you finally arrive at our target, the nanoparticle, sitting right in that incredible 1 to 100 nanometer sweet spot.
Section 2, why small changes everything. The magic of quantum effects.
Think of a chunk of gold. You immediately picture a shiny yellow metal, right? Well, not down here. At the nanoscale, gold actually appears red or purple. It's wild, but it completely flips our expectations of how materials should behave.
Why does this happen? When materials are reduced to the nanoscale, two massive shifts kick in. First, they gain an incredibly high surface area relative to their volume. And second, quantum effects begin to completely dominate their behavior. Because of these factors, materials can suddenly become dramatically stronger, incredibly lighter, or vastly more reactive than their bulk everyday counterparts. Their electrical, optical, and even magnetic properties change entirely. It's essentially like unlocking a hidden menu of superpowers for everyday elements.
Section 3. Building atom by atom. The mechanics of manipulating atoms directly. Okay, so how do we actually create these incredible materials? There are two primary methods, and they're basically perfect opposites. On one side, we have the bottom-up approach. Think of this like building with microscopic Lego bricks. Atoms and molecules are meticulously assembled literally one by one to construct intricate structures. On the flip side is the top-down approach. This is much more like sculpting. You start with a big bulk material and you etch, carve, or break it down until you're left with exactly the nanoscale pieces you need. Both of these approaches are absolutely essential tools in the nanotech engineering toolkit.
Section 4. Meet the nanoparticles, the microscopic roster and their superpowers.
Let's meet the cast of characters here, because this microscopic roster is incredibly versatile. We already mentioned gold nanoparticles, sitting in that 1 to 100 nanometer range, which are proving amazingly useful for targeted drug delivery, cancer therapy, and biosensors. Then you've got silver nanoparticles, famously used for their incredibly powerful antimicrobial properties, which aids in wound healing and water purification. Titanium dioxide and zinc oxide, they are the unsung heroes protecting us in sunscreens and air purification systems. Then there are carbon nanotubes. These are cylindrical structures used to make composite materials absurdly strong, and they're vital for advanced energy storage. Finally, we have quantum dots, tiny semiconductor nanocrystals that are totally revolutionizing imaging and display technology right now.
Because of this immense versatility we just talked about, nanotechnology broadly breaks down into 4 main arenas. First up, nanomaterials. Think of supermaterials like graphene, engineered for totally unique mechanical and chemical properties. Second is nanoelectronics, which is the driving force behind those smaller, faster computer chips and advanced sensors we all rely on. Third is nanomedicine, focusing on targeted drug delivery and early disease detection. And fourth, energy and environment, providing real solutions for a cleaner future through much better solar cells, efficient batteries, and powerful pollution cleanup.
Section 5. Real-world nano applications. How the invisible world powers everyday life.
Now, you might be thinking this all sounds like sci-fi, but the sheer ubiquity of nanotech in our modern lives is stunning. It's already integrated into smart textiles that magically resist stains or monitor your health. It's in the cosmetics you apply,
giving them smoother textures and way better absorption. It strengthens automotive parts and aerospace engineering, making vehicles lighter and much more fuel efficient. It's even making your sports equipment more durable and keeping groceries fresh longer through advanced food packaging. You are interacting with this invisible revolution literally every single day.
But perhaps the absolute most consequential application we're seeing is in nanomedicine. Imagine a targeted nanoparticle carrier successfully navigating the human bloodstream, completely bypassing healthy tissue to deliver medication directly to a specific cancer cell. Instead of flooding the entire body with really harsh treatments, nanotechnology allows for precise, targeted strikes. It's a massive, game-changing leap forward for healthcare, diagnosis, and treatment.
Section 6. Future impacts and challenges. Weighing progress against the risks. Of course, with great power comes a lot of responsibility. Researchers and regulatory bodies are actively investigating several serious concerns. Because these particles are just so incredibly small, there are potential health risks regarding how nanoparticles might accumulate in the human body over time. There are also unforeseen environmental impacts to consider if these nanomaterials start accumulating in ecosystems or our water supplies. Furthermore, the rapid, lightning-fast pace of this technology raises really complex ethical and regulatory issues. It highlights a critical, undeniable need for responsible use and safe production protocols all across the globe. But despite those hurdles, the ultimate goal of this field remains incredibly optimistic. To quote, nanotechnology is shaping the future atom by atom for a better tomorrow. By learning to manipulate the very building blocks of matter itself, we are opening doors to global solutions that were previously unimaginable.
Which leaves us with a massive question to ponder. How do we balance this incredible, atom-by-atom progress against the ethical and environmental challenges it inevitably brings? It's a question society is going to need to navigate together as we continue to unlock the deepest secrets of the nanoscale. Thank you so much for joining me for this explainer.